All right, the video today is going to be on tension segments using a Highpoint COD. As you see there, the weight that we're using today is 200 pounds of free weight, and so we just had it tied off just to simulate a load. The angle on the COD is a little less than 90, so loads that were expected to be on that COD are going to be about 360. I'm saying 350 if this was a true 90, but we say about 360. The rope comes down, travels down to our system that we're going to be using to hauling up. In this case, we're going to use a complex piggyback 9-to-1. We'll discuss what exactly that is in a minute. Attached, we have another load cell, and we have the MPD for our project capture and our COD at the anchor. All right. So what we're going to do is we're going to go ahead and discuss the tension segments we're expected to be on it. So if you look at the rope going from the weight up to the COD, so that angle is roughly 90 is pretty close. It's going to be a little bit more than 1.5 multiplier. So we're expecting on this rope here be a little bit heavier than 200 pounds. It's going to come down to our haul system. Like I said, this is a 9-to-1 complex piggyback system because I'm going to have two moving pulleys. I have a 5-to-1 here, 5 moving ropes coming off a moving pulley. It's a simple 5, and then I have a 4 off the Aztec, so this is my 4-to-1. So in theory, right, we look at it and we go, this right here, this rope is going to start at a 4. So if I have 4 units of tension coming in through my MPD and 4 coming out, that puts 8 units of tension here. Right, it's going to give me, whatever that unit's of tension is at 200. Let's say it's 23 pounds times 8 should be put on my enforcer. All right, we'll do the math here in a little bit. On this pulley, my 5-to-1, if I pull this line together, these two pulleys are coming together, it is a 9-to-1. So in theory, each tension segment is going to be around, like I said, 23 pounds, 22 point something pounds using a 200-pound load. So that's 200 divided by 9, right? So my 4 units of tension come in here, out the MPD, come up this line, travel, 4 units of tension, come up and hit my 5 attached to the cam, turns this into a 9. That's how I know it's a 9-to-1 complex system. So we're gonna go ahead and put some load on this and haul, and we're expecting about 360 up there at that anchor with that enforcer, which I have on a Bluetooth, and then we'll come back here and film what this is on the anchor point. All right, so this is going to be the COD pulley we have up top. So you see we have our system hooked up and the Bluetooth on it. All right, go ahead and start pulling slow. Pull in line with the pulleys there. And we're gonna watch this creep up as soon as the weight comes off the ground there. See in the distance, it's kind of blurry, but there it is. All right, it's coming up and here it comes. So 300 pounds, there you go. So yeah, 352 is at our highest, 350 around that range. Perfect. All right, now we come down to this one. Go ahead and keep pulling. And we're at 190, 186. So we'll give it a 190 on that one. So let's go back and do our math and figure out how close we are. All right, so what we're gonna do now is we're gonna go ahead and put tension. All I did was put an inline knot so it acts as my hand hauling on the 9-to-1 complex. So we're gonna go ahead and pull on that and to see what the scale goes to. This should read our units of tension through the mechanical advantage, right? So let's go ahead and pull slow. Right, nice and easy until we get lift with the 200 pounds. And just like we said, 24. Keep going. So we're about 32 pounds we have of force. So our tension segment technically is a 32. All right, more accurately, it depends on how accurate this is right now. I'm just holding still, we're at 24. So that would basically tell us what our tension segments are. We do our math and our tension, see how close we are. But we're losing some friction in the pulleys, so we don't know how efficient the pulleys are currently with the amount of weight that we have. But anyway, so that's what we're getting. We're getting about 30 pounds of tension pulled on the haul system.